What is the critical point where liquid and gas are indistinguishable? Imagine a moment where the difference between a liquid and a gas just disappears. It might sound like science fiction, but in thermodynamics, this is a real and fascinating point. When you heat a substance, it changes from a liquid to a gas through boiling or evaporation. But if you keep increasing the temperature and pressure, something extraordinary happens. The liquid and gas phases start to blend together, becoming one seamless state called a supercritical fluid. This special point where they become indistinguishable is known as the critical point. The critical point is defined by a specific temperature called the critical temperature and a particular pressure called the critical pressure. At the critical temperature, the substance's molecules move so rapidly that the liquid cannot hold onto its shape or density. Meanwhile, at the critical pressure, the molecules are pushed so close together that the difference between the liquid and gas phases vanishes. When both conditions are met, the substance enters a supercritical state. Think of it like heating water. Below the critical temperature, water boils into steam at a certain pressure. But above that temperature, no matter how much you increase the pressure, you can't turn the gas back into a liquid by simple compression. Instead, it becomes a supercritical fluid, which has unique properties. It can flow like a gas but dissolve substances like a liquid. This makes supercritical fluids very useful in industries like cleaning, extraction, and even food processing. In phase diagrams, the critical point is marked at the end of the vapor-liquid equilibrium line. This line shows where the liquid and gas phases coexist. When you reach the critical point, this line ends, and the two phases merge into one. This transition is important because it shows the limits of the traditional phase change process. It also explains why boiling stops being possible once the critical temperature is crossed. Understanding the critical point helps scientists and engineers design better processes. For example, supercritical carbon dioxide is used to extract caffeine from coffee beans because it can penetrate materials easily and dissolve compounds efficiently. It also helps explain why some processes are faster or more effective at high temperatures and pressures. So, the critical point is a fundamental concept that reveals the boundary where the usual rules of phase changes no longer apply. It highlights the fascinating behavior of matter under extreme conditions and opens up new possibilities for industrial applications. This point is a key to mastering how substances behave when pushed to their limits in the world of thermodynamics.